morning children, my name is Kartika, Assistant Professor working as the Assistant Professor in Department of Computer Science in Tirthangal Nadar College. Today we see about data structures and algorithms. This is very important for computer science student, this paper. In data structure, what is data? The data is nothing but a collection of information. For data structure, it can be defined as a logical relationship existing between individual elements of data. The data structure is nothing but for organizing and storing data in memory. Consider not only the elements stored but also the relationship to each other. So data is nothing but each and every data we can relate in data. Data can be related in the data structure. This concept can be divided into two types, linear and non-linear. In linear data structure, they are divided into four types: array, stack, queues and linked list. For non-linear data structures, graph and trees. First we see about what is linear data structure. In linear data structure, the data can be stored in contiguous memory allocation. It is continuity. For non-linear data structure, the data can be stored in non-contiguous, non-continuity. For array, it is a continuous memory allocation. For stack is also a contiguous memory allocation, and queue and linked list. For array can be start with the index value 0. The array can be represented at starting index value 0, and the stack is nothing but last in first out. It can be stored the data using this concept push and pop operation we can mainly use. For queue, it is also called as FIFO. NQ and DQ operation can be used. For linked list and for non-linear data structure, graphs and trees, in non-linear data structure, the data can be stored in non-contiguous, not continuous. So linear data structure means the data can be stored continuously. For non-linear data structure, the data cannot be stored continuity. So trees and graph are the best example for non-linear data structure. Time complexity. The time complexity is very important question in your data structure paper. It is very important 2-mark question. First, what is time complexity? The time complexity means the input size has a strong relationship with time complexity. As the size of input increases, so does the run time or the amount of time it takes the algorithm to run. So when the input, the size of the input is increased, automatically the time complexity will also be increased. Depending upon the size of the input, the time complexity may vary. So the time required by an algorithm fall under 3 types. Number 1, best case, average case, worst case. For best case, minimum time required for program execution. For average case, average time required. And then for worst case, maximum time required for program execution. These are the time required by an algorithm fall under 3 types. Time complexity. The time complexity can be denoted in some notations. The 3 types of asymptotic notations to calculate the running time complexity of an algorithm. The asymptotic notation, what is asymptotic notation is very important 2 marks for your university examination. Here there are 3 types of notations: big omega notation, big theta notation and big O notation. Big omega notation is used for best case of any algorithm, and big theta is notation used to define the average value of an algorithm. Big O is upper bound algorithm or worst case of an algorithm. Mainly we calculate the big O notation to find out the time complexity of an algorithm. Then another concept is space complexity. This is also very important. Both time complexity and space complexity. 2-mark questions, very important 2-mark question. Either they ask time complexity or space complexity. First we see about what is space complexity. It refers the total amount of memory space used by an algorithm or program, including the space of input values of execution. Auxiliary space plus space used by input values is equal to space complexity. How much memory it will be taken during the execution of the program or algorithm. So time complexity and space complexity. First we see about what is data structure, then what are the types of data structure. In types of data structure, there are 2 types: linear data structure and non-linear data structure. In linear data structure, there are 4 types. Number 1, array, linked list, stack, queue. For non-linear data structure, there are two types, trees and graph. Then what is time complexity and what is space complexity? Time complexity means how much time it can be taken during the execution by the algorithm or program. For space complexity, how much space it can be taken by the algorithm or program. It done by with the help of memory space. It is called a space complexity. Next we see about big word notation. Big word notation is nothing but the time complexity of algorithm most commonly expressed in big word notation is very important concept. Big word. Big word means how much time complexity. Each and every constant means order of 1. Logarithmic means order of log n. Linear means order of n. N log n means order of n log n. For quadratic, order of n square. Cubic, order of n cube. Polynomial, n power order of 1. For exponential, 2 power order of 1. So time complexity, what is time complexity? Is how much time it can be taken by the algorithm or program. So it can be notated by big one notation. Order of, it can be expressed as order of 1, order of log n, etc. Then we see about array. The array is important concept, very important question. It may ask 5 marks or 2 marks. First, what is array? An array is a linear data structure which is collection of data items having similar data types stored in contiguous memory allocation. What is contiguous memory allocation? Means continuity. Continuity. A of 0, A of 1, A of 2, continuous allocation. By knowing the address of first item, we can easily access all items and elements of an array. Here the memory location 200, 201, 202, 203. Here the index value, each and every time the array can be stored with the index 0, 1, 2, 3, 4, 5. Then these are the elements stored in the index. This is the index, this is the memory address, and this is the element. So this is the main concept. First, whenever we study array, first we know the index, first starting index is 0 and then the address value is 200, the element is u. So array is nothing but a linear data structure. It's a collection of data item having similar data types stored in contiguous continuity memory location. There are two types of array or three types: single dimensional, two dimensional or multi-dimensional arrays. So array, following the basic operations supported by an array: traverse, insertion, deletion, search, update. For traverse, print all the array elements one by one. For insertion, add an element at the given index. For deletion, delete an element at the given index. Search an element using the index or by the value. For update, update an element at the given index. What is traverse? What are the elements are stored in the array? That can be printed. It is called as traverse. What is insertion? If you want to insert the element in the array, you have to insert the element using the index. What is deletion? If you want to delete an element in the array, you use delete. Then what is search? If you want to search the particular element in the array, you have to search. The last one is update. If you want to update the element to 5 instead of 10, we use to update operation. These are the operations are used in the array. Number 1, traverse, insertion, deletion, search, update. So what is array? Array is a contiguous memory allocation. It can store the values or elements in the memory location. It can be stored with the index value 0 and it has a memory address. Then these are the basic operations: traverse, insertion, deletion, search, update. This question must or may ask this compulsory 5 mark or 2 mark questions. Note down. These are the types of array: one-dimensional array, multi-dimensional array. The elements are stored in contiguous memory allocation. The element accessed by using single index. 2-dimensional array representation. 2D means two-dimensional array representation. There are two types of ordering: row major ordering, column major ordering. So it is 0th column, first column, second column, 0th row, first row, second row. This is called as column index. This is called as row index. First row of the row is stored in the memory completely, then second row of the array is stored in memory completely, and so on till the last row. This is the 0, 0 means 0th row, 0th column. 0, 1 means 0th row, first column. 0, 2 means 0th row, second column. For example, first row, first column. First row 1, 0, then 1, 1. This is the first column, first row. This is the second row, 0th column. Second row, first column. Second row, second column. So this way we stored and retrieving the data with the help of row measure and column measure representation. Here two-dimensional array can stored in memory in two representation. Number 1, row measure representation. Number 2, column measure representation. With the help of this row and column, with in row measure representation, the storage of array element take place row wise. All the elements of the first row of the array are first stored in sequence followed by second row and third, fourth and so on. So two types of array we saw about, one-dimensional array and multi-dimensional array. Then we see about sparse matrix. Sparse matrix is another important 2-mark question, no doubt. So sparse matrix can be defined with a two-dimensional array. An array with m column and n row represent m into n matrix. There may be a situation in which matrix contain more number of zero values than non-zero values. Such matrix is known as sparse matrix. What is sparse matrix? More number of zero values than the non-zero values. In sparse matrix can be represented by using two-way triplet representation, linked representation. So what is sparse matrix? A sparse matrix contain more number of zeroth element. For example, here this is a matrix, here more number of zero elements comparing to non-zero elements. What is sparse matrix? It contains more number of zero elements comparing to the non-zero elements. Sparse matrix is, here we use how many rows? 5 rows. 1, 2, 3, 4, 5. Here how many columns? 1, 2, 3, 4, 5, 6. So 5 rows, 6 columns. Here how many values will be stored? 1, 2, 3, 4, 5, 6. So 6 values. We can use 5 rows, 6 columns. Total values, total element we can store 6 element. So what is sparse matrix? It can store more number of zero elements comparing to the non-zero elements. There may be situation which a matrix contain more number of zero values than non-zero values. So here we see about zeroth row, fourth column, value is 9. Then first row, first column, the value is 8. Then second row, 0, 1, 2. Second row, which row? Second row, 0th column, the value is 4. Then second row, third column, the value is 2. Here, 2 is where here? Fourth row, second column. Second column means 0th column, first column, second. So we use second column. Here 0 row, first row, second row, third row, fourth row. So fourth row, second column, the value is 2. These can be represented. It is called as triplet representation or array representation. Triplet representation can be represented in the matrix form. So here is the 5 rows we use, 6 columns and total element data stored is 6. Next one is sparse matrix linked list representation. In linked list, each node has 4 fields. These 4 fields are defined as row, column, value, address of the next node. Here we use 0 is the row, 0th row. Then 2 is the column, 0, 1, 2, second column. Then value is 0th row, second column, the value is 3. Then last one is address of the next node. Last one is address of the next node. Here once again 0th row, 0, 1, 2, 3, 0, 1, 2, 3, fourth column. Which one is? The value is 4. Then once again next to the address. Then first row, 0, 1, 2, second position 5. So this representation is the linked sparse matrix linked list representation. In sparse matrix there are two types, triplet representation, second one is linked list representation. In triplet representation we represent in the matrix. For in linked list representation we using the node. In each node, the node structure, it can be divided into four types. One is row, column, value, address of the next node. Can you understand? The sparse matrix is very important. You please note down, don't forget. It's important, 2 more questions. Then another one is stack. What is stack? The stack is a linear data structure that follow last in first out principle. Stack has a one end, whereas the queue has two ends, front and rear, contain only one pointer, top pointer pointing to the topmost element of the stack. So stack is one of the type of linear data structure. Stack is the type of one of the type of the linear data structure. A stack is also called as LIFO, last in first out, last in first out. Here only one pointer it will be, the stack can be defined as a container in which insertion and deletion can be done in one end known as top of the stack. The stack uses the following two primary operations: pushing, storing an element on the stack, and pop is removing, accessing an element from the stack. The two operations, push and pop. Push is nothing but inserting the element into the stack, and pop is nothing but removing the element from the stack. So stack is also called as LIFO. LIFO means last in first out. It is one of the type of linear data structure. The data can stored in continuously. The data can be accessed continuously with the help of array, index values, arrays. Here this is the last in first out. Whenever we want to push, the top element will be affected. Whenever we want to pop the element, that also the top of the element in the stack will be affected. Either push or pop, the top element can be affected in stack operation. So what is stack? We saw about what is stack. Stack is nothing but storing the data. It is a type of linear data structure. It is also called as LIFO, last in first out. Two main operation, push operation. Another one is pop operation. Push operation is used to inserting the element. Pop operation is used to removing the element from the top of the stack. Either pushing or popping only affect at the top of the stack. Then we see about applications of stack. Applications of stack is very important 5 mark question. Note down, very important 5 mark question. So stack can be used for expression evaluation and recursion. Stack can be used to check parenthesis matching in an expression. Stack can be used for conversion from one form of expression to another. Stack can be used for memory management. Stack data structure are used in backtracking problems. Then next we see about queue. Queue is a linear structure which follow a particular order in which operations are performed first in first out. In queue there are two operations, NQ and DQ. NQ means add an item to the queue. DQ means remove an item. In stack we use two operations, push and pop. Push is nothing but inserting the element. Pop is nothing but removing the element from the top of the stack. In queue concept, we use two operations, NQ and DQ. NQ means inserting the element. DQ means removing the element. These items are popped in the same order in which they are pushed. If the queue is empty, it is said to be underflow condition. If the queue is empty, we can say as underflow. If the queue is full, we can say what? Overflow. So NQ means inserting, DQ means removing. For inserting the element, the rear element will be incremented. For removing the element, the front element will be decremented. Dq means removing the element. It can affect the front variable. Nq means inserting the element. It can affect the rear. Okay, back side. Back side means whenever we add the element in the queue, it can be incremented by the rear value. The rear value will be incremented. Priority queue is similar to normal queue except each element have same property. The element with the highest property would come first in priority queue. Circular queue is also same thing. In given this is each time when insert a new item, we increase the back index. When we remove an item, we increase the front index. Here is a picture to illustrate the model, the few steps. If you want to insert the element in the queue, the back element will be, that is the rear element will be added. If you want to delete the element in the queue, delete the element, the front value will be incremented. Applications, there are two search techniques. Expression conversion is one of the application of this stack. What is expression conversion? What is expression? A plus B or B plus C or C plus D is the expression. A plus B into C. 2 plus 3 into 5 is the expression. Converting one form of expression to another is one of the important application of stack. Converting one form of expression to another is one of the important application of stack. Infix to prefix, infix to infix to postfix, these are the infix mean A plus B, prefix mean plus BA, postfix means AB plus. So A plus B, the operators between the operand is infix.